In this video, we are discussing physical and chemical changes and physical and chemical properties. These are our learning targets. First, let's talk about the physical and chemical changes that matter can go through. Now, matter goes through change all the time. Solid turns into liquid, liquid evaporates into gas. Those are physical changes. Sometimes we see a chemical change, like when we cook. That's always a chemical change. And so it's important to identify what kind of change matter is going through. Physical change is a change in appearance, but it's the same substance. You just do something to change the state, solid, liquid, to gas, or you change the size, it gets bigger, it gets smaller, or you're changing the shape. So for example, in some of these pictures, you see that someone is cutting paper. But is paper still paper? Yes, we didn't change anything to that but the size. When ice melts, solid ice is turning into liquid water. H2O is still H2O. It's still made up of the same substance. So that is an example of a change of state. When we crush an aluminum can, we're simply changing the size, right? And what about when we dissolve something? Like we're dissolving, this is Alka-Seltzer tablet into water, or dissolve sugar into water, or dissolve salt into water. We're just making sugar water or salt water. We're not actually changing what the salt is made up of. We're not actually changing what the sugar is made up of. When you dissolve something like solid into water, or sugar into water, or salt into water, that is simply a physical change. Other examples of physical change include bending or twisting, like bending or twisting a wire. That's just changing the shape. When you evaporate a substance, that's going from liquid to gas. When you freeze a substance, that's going from liquid to solid. You can grind something to change the size, like black pepper grinders, right? You have like the black pepper balls and you can grind them up so that it's smaller size, like flakes. So again, a physical change, it's just a change of state, solid, liquid, gas, or size, or shape. So one of the physical changes that we just talked about is when matter changes states. So from solid to liquid to gas, from gas to liquid to solid. So as we add the heat, we know that solids will melt into liquid. You continue to add the heat, liquids will evaporate into gas, and vice versa. If you cool it down, gas will turn to liquid, and then liquids will freeze and turn into solids. Well, to show this change, we can use what we call a heating curve. And a heating curve is this graph that you see on your screen. So on the graph, we see that the y-axis is temperature in degrees Celsius, and the x-axis is the heat being added. So as you add the heat, we see that the graph is going up and up and up, right? It's increasing. So first, let's label our graph. We have our solid, that's where we start at low temperatures and as we start to add the heat. And then we have solid and liquid states. So if we take water, for example, we have ice, that's solid, and as we heat it up, at one point we're going to see both the ice and the water, liquid water. Right? So this is where we see both solid and liquid. We continue to heat it up, then we have liquid, and then as you go on, you have liquid and gas. So if you think about putting water into a pot and putting it on your stove, you're boiling the liquid, so you have liquid, but then once you start to see this steam, all right, that's the gas, so you have both liquid and gas. And then you will eventually have all gas, right? And so these are your states, okay? So the substance will go through phase changes. And make sure you're labeling your graph that you have on your notes, okay? So the first phase change is melting. So as a solid turns into a liquid, it goes through a melting phase change. And as we continue to add more heat, liquid to gas is vaporization or evaporation. So let's say that we cool it down. So doing the opposite, gas to liquid, is condensation. And notice where the arrow is pointing, right? So it's going from gas to liquid. And then from liquid to solid is melting. So these are the 4 phase changes. Probably, hopefully, nothing new to you guys. Now we can talk about these phase changes as absorbing heat or energy or releasing heat or energy. So as heat is being added, the substance is absorbing the heat, it's absorbing the energy, and so the 2 phase changes that we talked about, melting and vaporization, these are endothermic, okay? So endothermic means energy absorbed. The opposite, when a substance is freezing or going through condensation, that is exothermic, so energy is being released. So again, this is a heating curve, and if we were to do the opposite, meaning cool it down, we see this graph here, or you could see something like this, and this is simply just called a cooling curve. And one more thing that I want to point out is, notice that when a substance is changing states and going through a phase change, what's happening to the temperature? Well, temperature remains constant, right? And in fact, this is a substance's melting point, and here is the substance's boiling point. What's happening at the other regions? Well, temperature is increasing, right? So temperature increases, and then it stays constant, and then it increases again, and it stays constant, and then it increases again. So we're actually going to come back to the heating curve later on in the year. Now, a substance goes through a chemical change when there's a change in the actual substance, meaning it's clear that a chemical reaction has occurred. For example, cooking. You cook an egg, that has completely changed, right? You can't go back to what the egg used to be. And even baking a cake, for example, you put all the ingredients together, you put it in the oven, you take it out of the oven, and it's completely changed, right? So chemical reaction has occurred in all those substances. Other examples include explosions and burning. Whenever you're dealing with fire, once something lights up, you have ash, you can't get the original substance back, right? If you're burning logs for a campfire, you can't get the original logs back. Tarnishing, it's an example with the spoons. Sometimes our silver will tarnish. Rust, we'll see rust in our cars and bikes and skateboards, especially if they've been left outside. And so iron rusts because it reacts with the air and the moisture. So again, a chemical change is when the substance actually changes to something else. You get something completely new that you didn't have before, whereas a physical change is simply just a change in appearance. So how do we know that a chemical change has taken place? What are some clues that we can look out for? Can you list maybe 2 of them? Well, some indications include gas formation. I'm not talking about you're boiling water and then all of a sudden you see gas. This is you put 2 things together and a gas forms when it wasn't there before, right? You're making something completely new. Like when you put baking soda and vinegar together, you are making carbon dioxide gas. Sometimes we see a color change. So for example, when food rots, sometimes there's a color change there. Right? Sometimes there will be a temperature change. And this is when you're not adding any heat to it or not cooling it down. It's just you put the 2 substances together and it either heats up or you'll feel it a little bit cooler than it originally was. You'll have an odor that comes out of it. Again, not always, but sometimes. And the last one you probably have never heard about is the formation of a solid, which we call a precipitate. So this is shown in the picture here. And this is, for example, 2 liquids, 2 clear liquids that we're putting together. And what you see here is a precipitate. It's something solid-like, and it also changed color. You have two clear liquids that made a yellow precipitate. So now let's take a look at some examples of physical and chemical changes, and let's talk about why it's going through that type of change. So first, we're going to start with the melting of ice. We know that this is a physical change because it's simply changing states. It's going from solid to liquid. When you dissolve salt into water, that is a physical change. You can actually evaporate the water back out so that you have the solid once again. Cutting paper, again, it's just a physical change because it's a change in size. Melting chocolate, again, it's just going from solid to liquid, change in state. When you're bending metal, you're not doing anything to the metal, you're not making anything new except simply changing the state. Again, when you're grinding, for example, grinding sugar, you're just simply changing the size of the substance. So now let's take a look at some examples of chemical changes. Burning sugar is an example of a chemical change. You have a change of odor here and a change of color as well, right? Food rotting, you have change in odor, change in color, sometimes gas formation as well. Burning sulfur would be a chemical change. You don't want to smell that. Digesting food is a chemical change. Now that we've gone through some examples of physical and chemical changes, can you also think of a few physical and chemical changes? Chemical changes can also be endothermic or exothermic. A chemical change is endothermic when the temperature decreases. So again, this is not when we're adding heat or taking away heat. It's just a chemical change happens and it feels cooler. A chemical change is exothermic when the temperature increases, so it'll feel warmer. So let's go through these two practice problems. Determine whether each of the following is a physical or chemical change and whether it is endothermic or exothermic. The first one, heat was applied and solid melted into a liquid. So what's happening here? A solid melted into a liquid. It's simply melting. It's going through a change of state. So that is a physical change, and melting is endothermic. Second example, a solid was added to a liquid, the color changed, the temperature increased, and bubbles formed. Well, here are some indications of a chemical change, right? There's a color change, a temperature increased, and bubbles formed. So this is a chemical change, and is it endothermic or exothermic? Well, it says that the temperature increased. It got warmer. So that tells us that this chemical change is exothermic. Now, some of you may be a little bit confused right now and thinking, wait, solid is melting into a liquid. Isn't that getting warmer? That's why the solid is melting. And so shouldn't that be exothermic? Well, remember, when we talk about chemical change being exothermic, we're not saying that we're applying external heat. It's just that as the substance changes, it feels warmer or it feels cooler, but there is no external heat that's being applied to that substance. Whereas when we're melting the solid into the liquid, we're actually applying that heat, and that is why it feels warmer, right? Because we're getting the warmth or we're getting the heat from that external source. So I don't want you to confuse the two terms with the physical and chemical changes. The last thing we're going to discuss is properties of matter. Now think of properties as characteristics. These are ways to describe a substance. First, let's start with chemical property. This describes how a substance reacts. The substance combines with or changes into one or more other substances. It is the ability of this substance. For example, iron can react with oxygen and water, and therefore it rusts. No other metal actually rusts. It's just the ability of iron. It is the chemical property of iron. When we put baking soda and vinegar together, they react to release carbon dioxide gas. It is a chemical property of these two substances put together. When a substance is flammable, we say that that's a chemical property. When it can react with acid, when it is inert, when it doesn't react. Okay, so these are ways to describe how a substance reacts, the ability of a substance to react. When we talk about physical properties, these are characteristics that can be observed or measured without changing the sample's composition. These are properties we use to describe a substance. For example, we can talk about shape, we can talk about color, we can talk about its texture, and then we can talk about its mass, its volume, its state of matter. This is currently solid, liquid, gas. We can talk about metals being ductile or malleable. So malleable means the ability to flatten or hammer the metal down into a really thin sheet of metal. Ductile has to do with making it into a wire or a very thin wire. We can talk about conductivity. We can also describe substances based on its boiling point, freezing point, melting point, density. These are all examples of physical properties.